Good morning. So today we're going to be talking about applying the properties of operations to generate equivalent expressions. So first we need to figure out what those properties are. Expressions with the same value, like 12 plus 7 and 7 plus 12, are equivalent expressions. Because if we add 12 plus 7, we're going to get 19, and if we add 7 plus 12, we're also going to get 19. You can use the commutative and associative properties to write equivalent expressions. So please add those into your notes. Add that vocabulary in there if you're using a note guide, or add these two sentences into your notebook. Okay, so commutative property. I'm going to scroll down so you can see it a little bit better. The commutative property means that changing the order of the addends or the factors, so the numbers that you're using in these math problems, does not change the sum or the product. 5 plus 8 is going to be the same thing as 8 plus 5. And 5 times 8 is going to be the same thing as 5 times 8. Let me say that again. 5 times 8 is the same thing as 8 times 5. Both products are equal to 40, so that means both sides of this equal sign are balanced. They are equal to each other. Moving on to the associative properties. Again, pause the video as you need to in order to get your notes into your notebook. The associative property means that changing the grouping of the addends or the factors, which are the numbers that you're using, does not change the sum or the product. So what I mean by grouping is that I grouped 7 and 4 together because that tells me that I'm going to solve 7 plus 4 first before adding the 2. However, if I group the 4 and the 2 instead of the 7 and the 4, I'm actually still going to get the same answer. The associative property tells me that when I am adding more than 2 numbers, I can group them in whichever way, and that'll help me group different numbers to combine like terms later on. Same thing with multiplication. 7 times 4 and then multiplied by 2 is the same thing as 7 times the product of 4 and 2. And that's how we write it using algebra. Moving on, we're going to use these properties to actually simplify expressions with variables. So that's where algebra comes into play, and that's why we're going to use these properties to help us decide how we can simplify them and make them as short as possible. So you'll see that 12 and x are grouped in this expression. Grouped just means that they are in a set of parentheses to solve first. I can't simplify 12 plus x. I don't know what x is, so I can't add anything to it. So I'm going to use the associative property, and I'm going to group 7 and 12 so that I can add that first and then add x. And I know that 7 plus 12 is 19, so 19 plus x is my final expression. So I'm taking this expression and I'm simplifying it by making it as short as possible. I can't do anything now because I don't know what x is, so I can't simplify it anymore. Let's try another example. Simplify the expression 6.1 plus x plus 8.4. So we're going to use two properties here. We're going to use the commutative property by talking about the order in which we add these terms, and we're going to be talking about the associative property by grouping a different set of numbers so then we can end up combining them. So I have 6.1 plus x plus 8.4. So what I'm going to do is within this set of parentheses, I'm going to use the commutative property to switch the order. So now I have x plus 6.1 plus 8.4. Now I'm going to use the associative property, and instead of grouping x and 6.1, I'm going to group 6.1 and 8.4 because I can actually add those two terms together. Now I'm going to add those, and I'm going to end up with 14.5. and since I can't add x to 14.5 since I don't know what it is, the simplifying of this expression is done. Now, we're going to use an example with multiplication. So I see that this number next to parentheses is implying that we're going to multiply. So I can rewrite this as 5 times 11y so that I can actually group the 5 times the 11. So now I've actually added my own multiplication symbol. Even though it was really there in the first place, I've added it so I can visually see it, because now I can multiply 5 times 11 and end up with 55y. Let's go ahead and try some of these on your own. So one way to check whether expressions are equivalent is to evaluate each expression for any value. So let's pretend like we know what x is, and then you can actually plug it in and see if where you started and where you end is equal to the same thing. So let's simplify these three expressions. So start with the first one here and try that on your own. You're going to use the associative property and the commutative property. Okay, for problem number 1, you should have ended up with the answer of 19 plus a. First you can switch a and 9, and then you can group the 10 and the 9. For answer number 2, you should end up with c plus 1 and 1/6. And for answer number 3, you should end up with 20n. That is as simplified as all three of those expressions can get. All right, so talking about the addition property of 0. The sum of any number and 0 is just that number. So we're not changing the value. So that property helps us understand that no matter what the number is, if we add 0 to it, we're going to get that number. Now the multiplication property of 0 and 1 is very similar. If you multiply, so the product of any number, if you multiply that number by 0, you're going to get 0. And the product of any number and 1 is always going to be that number. So 9 times 0 is 0, and 4 times 1 is 4. Okay. Moving on to some examples down here. We are going to use the associative property of multiplication because we're actually going to solve 9 times 0 first. So first I do that in my head, and I know that 9 times 0 is going to be 0, and 0 times any number, regardless of what it is going to be 0. This next example, I'm first going to group the 4.5 times 1 because I know that any number times 1 is going to be itself. So I can either group the 4.5 times 1 or the r times 1. And I know that whatever I get, whatever number I have multiplying by 1 is going to end up with that same number. So then I have 4.5 times r, and I can simplify that to 4.5 times r, where the number is next to the letter. All right. So moving on to another example. You and 6 friends play on a basketball team, and the sponsor paid $100 for the league fee, X dollars for each player's t-shirt, and $68.25 for trophies. Write an expression for the total amount the sponsor paid. So you're adding the league fee, which is $100, the cost of the t-shirts, which is 7 times the number of each player's t-shirt, okay, because it's you and 6 friends, so 7 total, and the cost of the trophies, which is $68.25. Now I can use the commutative property to put the $100 next to the $68.25 because I can actually add those first. So the expression for the total amount is going to be 7x plus $168.25. I don't know how much each player's t-shirt is, so that's as far as I can simplify it. You can try a couple of these on your own in your notebook. I'm going to go ahead and have you pause the video, and then you can take a look and take a look at the properties that you have in your notes to actually use them to solve. Okay, so for this first problem, number 4, you're actually going to end up with the answer of 0, because 0 times b is going to get 0. Regardless of what number b is, you're still going to get 0, and I know that 0 times 12 is 0, so that is the answer for problem number 4. For problem 5, I'm going to multiply 1 times m, and I know that's just going to get me whatever m equals. So I'm going to end up with the answer of 24m. For this problem here, I'm going to use the associative property to group the 15 plus 0 instead, and I'm going to add those together to get 15, so then I'm left with t plus 15. The answer for number 7 is 7x plus $154.75. So make sure you have all this included in your notes. You can use this on the homework. Please refer to this video as you need to. Otherwise, we will be catching up on the answers towards the end of class, and we will review tomorrow when you come back. Please let me know if you have any questions.